Qualitative Analysis, the test for cation. In this video, you will get to learn about the procedure in conducting the test for cations and the results you should expect to get for 8 cations in our syllabus. What are cations? Cations are positively charged ions. They are generally formed when metal atoms lose electrons. Examples of cations are the sodium ion, Na+, magnesium ion, Mg2+, calcium ion, Ca2+, copper 2 ions, Cu2+, iron 3 ions, Fe3+, zinc ion, Zn2+, and so on. Are there cations that are formed from non-metals? If you have thought of the hydrogen ion and the ammonium ion, then bingo! You are right. Amongst the many cations that are available, there are 8 cations that you will be required to know in specific testing. They are zinc, lead-2, aluminium, calcium, copper 2, iron 2, iron 3, and the ammonium ion. The basis of cation test is really from the reaction of alkalis. Details of these reactions can be found in your acid-bases notes. Other than the usual neutralization reaction of acid and alkali, alkalis also react with salt solutions to form metal hydroxide and another salt. The metal hydroxide that is formed comes from the metal cation found in the initial salt solution. Depending on the identity of the metal cation in the original salt solution, we have different solubility of metal hydroxide produced. Most metal hydroxides are insoluble and they are formed as precipitates. A precipitate is a solid formed upon mixing of two solutions. By looking at the color of the metal hydroxide formed and its solubility in excess of alkali gives information about the cations present in the solution. Alkalis also react with ammonium salt to give salt, water, and ammonia gas. This is the reaction that we use to determine the presence of ammonium ions. The production of pungent ammonia gas that turns moist red litmus paper blue gives a good indication that ammonium ion must be present in the initial salt solution. Typically, the alkali used for cation tests are aqueous sodium hydroxide and aqueous ammonia. All sodium and ammonium compounds are soluble. Hence, these alkalines are able to dissociate and produce hydroxide ions to precipitate other metal ions, forming insoluble metal hydroxides. When performing the QA test for cation, you will need to start with a salt solution, which is the unknown. If the unknown given is a solid, add water to dissolve it such that a solution is obtained. Add a few drops of the alkaline into the test tube containing the unknown solution. The alkaline can either be aqueous sodium hydroxide or aqueous ammonia. Shake to mix the content. Observe if there are any precipitate formed in the mixture. Take note of the color of the precipitate. before adding an excess of the same alkaline to the mixture. Shake to mix the content again. A glass rod is sometimes used to ensure complete mixing. Some metal hydroxides are soluble in an excess of the alkaline due to the formation of complex salts. By checking if the precipitate dissolves in an excess of the alkaline, allows the identification of possible cations present in the unknown. All observations must be recorded, regardless of positive or negative results. This is important in QA as the negative results will serve to eliminate the presence of certain ions. These are the steps to go about testing for metal cations. The ammonium ions, on the other hand, requires a slightly different procedure, which we will examine later on. Let us take a look at the actual conduct of the cation test. Do make reference to the details of the results of the cation test in your notes. Let us start by looking at the zinc ions. 2 test tubes are filled with a sample of zinc solutions. We will be using aqueous ammonia and aqueous sodium hydroxide to test for the presence of zinc ions. A few drops of aqueous ammonia and aqueous sodium hydroxides are added to the sample of zinc solution. The contents are stirred for even mixing. We notice that a white precipitate is formed in both test tubes. Upon addition of an excess of each alkaline, you notice that the white precipitate dissolves in both alkalines to form a colorless solution. Next, let us examine the lead-2 ions. When a few drops of aqueous ammonia and aqueous sodium hydroxides are added to the solution containing lead-2 ion, a white precipitate is formed. The white precipitate has a powdery texture. When an excess of each alkaline is added, we notice that the white precipitate dissolves in an excess of sodium hydroxide, forming a colorless solution. But the white precipitate remains insoluble in an excess of aqueous ammonia. Moving on, we'll look at the aluminum ion. When a few drops of aqueous ammonia and aqueous sodium hydroxide is added to solutions containing aluminum ion, we notice that a white precipitate is formed in both test tubes. The precipitate is gelatin in texture. In addition of an excess of the alkaline, the white precipitate dissolves in an excess of aqueous sodium hydroxide, forming a colorless solution, but the white precipitate remains insoluble in an excess of aqueous ammonia. Notice that both lead-2 ion and aluminum ion gave similar observations to the cation test. How then can we distinguish these 2 ions? Do discuss this with your respective chem teachers to find out more. Moving on, we'll examine the calcium ion. Notice that when a few drops of alkalines are added to solutions containing the calcium ion, a white precipitate is formed with aqueous sodium hydroxide, but there is no visible change with aqueous ammonia. Upon addition of excess aqueous sodium hydroxide, the white precipitate remains insoluble. Since there is no precipitate formed when a few drops of aqueous ammonia is added, there is no need for us to conduct the further test using an excess aqueous ammonia. Moving on, let's take a look at the copper 2 ions. When a few drops of alkalines are added to the solution containing copper 2 ions, blue precipitate is formed. Upon addition of an excess of the alkaline, the blue precipitate remains insoluble in excess aqueous sodium hydroxide, but the precipitate dissolves in excess aqueous ammonia to give a deep blue solution. Next, we have the iron 2+. When a few drops of alkalines are added to the solution containing iron 2 ions, a dirty green precipitate is formed. The dirty green precipitate is insoluble in excess of both alkalines. Finally, with the iron 3+. When a few drops of the alkalines are added to solutions containing the iron 3 ions, a reddish-brown precipitate is formed. The reddish-brown precipitate is insoluble in excess of both alkalines. Do note that the precipitate formed from cation tests are metal hydroxides. These are some of the possible results upon the addition of excess alkaline to the salt solution. Notice the difference between how a solution and a precipitate look like. A solution is a homogeneous mixture. It is clear and light passes through very easily. A precipitate is a solid form when two solutions are mixed together. It suspends in a solution, forming a suspension. Are you able to list out some of the information regarding the possible cations present in each of the solution? Next, we move on to the ammonium ion. The ammonium ion is naturally present in aqueous ammonia. Hence, there is no need to test for the ammonium ion using aqueous ammonia. If the unknown solution is suspected to contain ammonium ion, we can add a few drops of aqueous sodium hydroxide into the test tube. Shake to mix the content. Since ammonium compounds are soluble, there should not be any precipitate formed. In other words, there should be no visible change. We then proceed to warm the mixture gently and place a piece of moist red litmus paper at the mouth of the test tube. If a pungent gas is evolved and the gas turns the moist red litmus paper blue, it indicates the formation of ammonia gas. Hence, the unknown solution would have contained the ammonium ions. Let us take a look at the actual testing of the ammonium ion. Aqueous sodium hydroxide is added to a sample of solution containing the ammonium ion. There is no precipitate formed. We then proceed to warm the mixture gently. When a piece of moist red litmus paper is placed at the mouth of the test tube, the litmus paper turns blue. We have completed the cation test segment. Next, we will move on to the identification of anions.